Hello students, welcome back to my channel. Today I am going to start a new chapter of class 10 syllabus, that is real numbers. This is new chapter for my sessions, but this is the first ever chapter in your NCERT textbook. Now, real numbers chapters, the very first topic is Euclid's division lemma. So before we go to Euclid's division lemma's main part or in details, we need to know some preliminary ideas, some preliminary knowledges. So the first thing that you have to know for this is division, a normal division process. So think about two numbers, any two numbers, what is coming in your brain immediately, you can take that. Suppose I am taking 4 and 7, right? So this 4 and 7, obviously 7 is the larger number, so 7 will be dividend and 4 will be divisor. So if we dividing 7 by 4, it will be like this. 4 ones are 4, 3. You can do it like this. When we were like you, we actually did like this, but actually this is not okay. This is the actual process. 4 ones are 4, that means it's 3. So from this process we have got that 7 is equals to 4 into 1 plus 3, where 7 is dividend, 4 is divisor, 1 is quotient and 3 is the remainder. From this you all know the statement of that is dividend equals to divisor into quotient plus remainder. And this particular statement is the statement of Euclid's division lemma, that is dividend equals to divisor into quotient plus remainder. Okay, the way we have got like this, 4 into 1 plus 3. Now why lemma? What does it mean by lemma? Lemma is a mathematical statement which is already proven by many more examples, and it can be used for proving other mathematical statements, and that is called a lemma. Okay, so Euclid's division lemma's particular statement is for given integers this is the statement of Euclid's division lemma I am writing. For given integers a and b, there exist unique numbers q and r such that a is equals to bq plus r, where a we have taken as dividend, b divisor, q quotient and r is the remainder, where this is only valid where 0 less equals to r less than b. Why this 0 less equals to r less than b? So we have written the whole statement of Euclid's division lemma But why 0 less equals to or less than b? Why this needs to be written? So, if you take any divisor to divide any other number, think about the same one. Suppose I am taking 3 as the divisor and 24 as the dividend. Okay. So then you are dividing 24 by 3. Then you are getting remainder as 0, right? Remainder will be 0 because 3 is the 24. So 24 is the multiple of 3. That means remainder will be 0. Suppose I am taking 23. Then remainder will be 2. If I am taking 22, remainder will be 1. If I am taking 21, remainder will be 0 again. You go upward 25, you will get the remainder as 1, 26, 2, 27, again 0. So, we are having possibilities for remember when 3 is the divisor. What are the possibilities of remainders? Remainder 0, 1 and 2. There is nothing else, right? 0, 1 and 2. Okay. So I am just writing over here for 3 we have got 0, 1 and 2. Right? Think about other divisors. Suppose I am taking the divisor as 5. Then and dividend as suppose 27. This is the division. Then 5 5s are 25. So remainder is 2. You take 28. Remainder will be 3. 29. Remainder will be 4. 30. Remainder will be 0. 31. Remainder will be 1. 32. Remainder will be 2. So again we started with 2, we came to 2, and then rest of the things will be recurring part. So for 5 we are getting the remainder possibilities starting from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Can you see any similarity here? I hope so. What is the similarity? Similarity is, wait, little bit light problem. I hope now you can see. So similarity is that for 3, remainder possibilities starts from 0 and going upward, but before 3 it stops. Before 3, 0, 1, 2. For 5 also it starts with 0, but it stops just before 5. 0, 1, 2, 3, 4. So for 3 possibilities, but starting from 0 and not 3. For 5 possibilities starting from 0 but not 5. Okay. So you can see that suppose 0 is always there, right? So remainder can be 0. That means 0 less equals to remainder. Remainder can be either 0 or more than 0. Less than the divisor. It can't be equal to the divisor. No time it will be equal to the divisor. So it will always be less than the divisor. And what is the divisor? We have taken the divisor as B. So I hope now you have understood why 0 less equals to R less than B. Okay. Now Euclid's division lemma. This one Euclid's division lemma. Now what is its practical application? When you talk about its practical application, the first practical application is to find out HCF of two numbers. HCF of two numbers, when finding HCF of two numbers, we have done many methods. But this one is depending on Euclid's division lemma, that means this divisional process, main divisional process, and you need to write down in a particular way. Now, to find HCF by using Euclid's division lemma, all these steps for calculation are called Euclid's division algorithm. Algorithm means steps to find out something. Okay. So mathematical steps. Now we will be doing Euclid's division algorithm. Or algorithm. Anything you can pronounce it. Algorithm or algorithm. Euclid's division algorithm, this is actually about the steps. How we are finding HCF of two numbers. So, for example, I am taking from your book. For example, I am taking 148 and 124. These are two numbers. You need to find out its HCF by using Euclid's division algorithm. How will you do? You can see that 148 is the larger number and 124 is the smaller number. That means 148 will be the first dividend. For this, if you want to do it more perfectly, actually I can say, then you always make it rough. Division process, long division process for finding HCF. This is like this. 124 minus it's 34. Okay. Then this one it's 124. 24 5s are 120. It's 4. Then 24. 4 6 are 24. And this is 0. So once we have got 0 in this long division process, we will stop over there. And then last division's divisor, that means 4. Last division's divisor is HCF. Right? This process I think everybody has done already in the lower classes. This is the process to be written like this, means vertical calculations. Euclid's division algorithms answers to be written horizontally in lines. So we will take individual divisions. Look how many divisions are there. 1 division, 2 division, 3 divisions. 3 different divisions are there. So our steps also will be 3. How I am writing? The first one, the formula dividend equals to divisor 124 is the divisor into 1 plus 24 plus 24. Then we will take this one as dividend and 24 as divisor into 5 plus 4. Again 24 will be dividend and 4 will be the divisor. 4 into 6 plus 0. So once we have got 0, the last steps divisor will be HCF. That means 4 will be HCF. So now you have understood that why I told to do it in rough, because this is very well known process. So if you are writing it in the rough, then writing these steps will be very easy. Okay, so I hope you all have got the idea how we are doing it. Okay, this is Euclid's division algorithm, which is to find out HCF of two numbers. And after finding this, you will write the answer that HCF of 148, 124 equals to 4, and that is the answer. Okay. Okay. So I hope you have understood up to this. Now I will be doing some of the questions from your exercise. So everybody please open your exercise. Exercise 1.1. Question number 1. Question number 1 is very simple. Everybody can do, because you are just apply the algorithm process like this, nothing else. Question number 2. So that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Any positive odd integer can be written in the form 6q plus 1, 6q plus 3 or 6q plus 5. How we can prove this mathematical statement? It's very simple. These type of many questions are there in your book and in other books also, so you can explore all these questions. These are very easy. 6q, so we will take the divisor as 6. Let n be any integer. I am not mentioning odd or even now. Any integer, and 6 is the divisor of n. 6 is the divisor of n. Now, by Euclid's division lemma, for any two integers a and b, suppose these two are a and b, there exist two unique numbers, that means quotient and remainder, and the form will be like this: n is equals to 6q plus r, where look at the divisor. So 0 less equals to r less than 6. That means you can write down. So r can be any one of 0, 1, 2, 3, 4, 5. Less than 6 it must be. So we have got 6 cases. 6 possibilities of r leads us to 6 cases. So case number 1. Case 1, when r equals to 0. r equals to 0 implies n equals to 6q. It is quite obvious n equals to 6, which is an even number. Even number multiplied with any integer will give us even number again. That means this is even. Okay. Case 2. This logic must be written. R equals to 1. N equals to 6q plus 1. Odd. Why odd? Because even plus 1 odd will be odd. Even just we have proved it. So even plus odd is odd. R equals to 2. N equals to 6q plus 2. Obviously will be even, because even plus even. Case 4. R equals to 3. N equals to 6q plus 3. This will be odd because 3 is odd. Case 5. R equals to 4. N equals to 6q plus 4, that is even again with the same logic. Case 6. R equals to 5. That means R equals to 6q plus 5, which is odd. That means we have got our answer. We have to find out the expressions for odd numbers, and we have got all these 3 expressions as odd numbers, and you can see the questions heading. That means we can write down now. Therefore, for any positive odd integer can be written in the form 6q plus 1 or 6q plus 3 or 6q plus 5. In this way, you can do question number 4 and question number 5 of the exercise 1.1, and you can practice for finding HCF from the questions exercise 1.1 question number 1. So students, this is all about today's session. So I hope you will have understood it, and we will meet in the next video with any other topic. Till then, have a good day.